So thank you everyone and welcome back again after the last coffee break. We have the last session and we are together with Richard Bosch from Axual and yeah, he's going to talk about how to survive managing Strimzi in an enterprise. So it's to you, Richard.
Thank you, Pavel. So thanks for joining me. Last talk of the StrimsyCon. I hope you've enjoyed it so far. I know I did. So I'm Richard Bosch. I'm developer advocate at Actual, and I'm here to talk about surviving managing Strimsy in an enterprise. So why do I say that in an enterprise? I work for Actual, and we build and maintain the Actual platform, which is, amongst other things, a cloud service or your own platform based on Strimzi. Before I did this, I was also doing implementation. So I was focusing on embedded systems, the ESB, worked a lot with integration systems. Of course, there's also some play. I also just go around taking pictures, love air shows. So for me, it is just fun to have technology and, uh, well, basically anything surrounding technology and doing something with photography. So let's talk about managing Strimzi in an enterprise. The enterprise we're talking about is a bank in the Netherlands. And in 2015, they decided they wanted to go to a 100% digital bank and become a real-time business. Um, they started designing, analyzing their systems, and they came up with a product or a service called the Business Event Bus, where a solution where things that happen can be captured from anywhere and delivered to anywhere for processing. It relied on consumers and producers not knowing about each other and uh, being generally available within the enterprise. It says here business event bus. The focus here was on business events, so organizational events, and not just technical events like you often also see with Kafka. So what did they envision? Well, the first use cases were based on transaction processing and, for example, alerting. If you've got you can set up an alert for your mobile phone, you get a text message that the money was transferred or your balance is getting too low. In the previous implementations, the delays went up to 15 minutes sometimes. That needed to be improved. But they already envisioned if this is a successful implementation, we have more use cases. As you can see, these are quite a list, and they have just started growing and growing. Needless to say, I'm still here with Actual. Those use cases were a success, and basically they are all now implemented. So when I'm talking about an enterprise, we usually go into business style stakeholders, data owners who want to say, I'm responsible for a certain type of data. I want to be in control. Architects that want to have a stable, ready to go platform. Developers want, of course, develop. They want to be not be limited by processes or by tools. They just want to develop, deploy, run. Then we have operators that want, of course, predictability, maintainable systems. And often you work with procurement because they want to have vendors that the organization can rely on. So at the first, only a couple of these were relevant. Procurement was not that relevant at that stage. But the data ownership and the future-proof platform was very important. So we came up with some initial requirements and challenges. For our deployment, we wanted TLS communications, encryption. It needed to be high available in multiple data centers. Data needed to be replicated. They wanted to use TLS client authentication, and authorization was required for all activities. This is 2015. Kafka is at 0.9, and Strimzi isn't even there yet. So the TLS was just introduced. Mirror Maker was there, but was also limited. Stretching a cluster across data centers is technically possible, but a challenge as well. And setting up and maintaining the access control, well, that was all manual work. And then we move to the management part. And I mean with management, the operations, the definitions of data. So they only wanted AVRO schema support. There was a single support operations team. The access control was controlled. The access control was very strict. So they wanted separation of roles to control access to topics and applications. And most of all, the business is responsible, so they should be able to approve access to a topic. So what are the challenges here? Well, we need schema libraries. We need to maintain registrations and the onboarding business clients and coordinating all those access requests. So let's start with the implementation first. We decided on 2 clusters. Don't go with stretched because there was too much issues with latencies. We had a transaction system and a notification system, and they will be producing on one of the data centers. But there was a requirement for high availability and failover. So that means that there needed to be a second data center, and that means data synchronization. So we set this up. We built our own connectors to optimize the data synchronization according to our requirements. We set up the processes, the first processes for onboarding. So what was our job in operations? Well, we monitor everything, usage. We add topics. We update access controls. We onboard teams, developers, business owners, and maintain the libraries. And in the meantime, we also did technical collection of data to make sure that everything was up and running, which is quite a lot for a single team. This was a typical day. Someone comes by and I want to publish an event. What should I do? Someone else is saying, well, someone wanted to consume. Are they actually allowed to consume? And then 5 other people come by with other questions. So a typical flow in this case, scenario, 2015, was the developer needs access. Okay, sure, I'll tell them it's going to be needed. We need permissions, I'll ask them. So I asked the owner if they accept. And they said, well, I have no idea why they want to do this. I'll talk to them and get back to you. Sometimes a couple of days, sometimes a couple of weeks later, yes. Well, nice. Now I can finally continue while keeping track of my paperwork. Schema updates, I've written down the process. I'm not going to go through it, but basically it's Git based. It's a project that needs to be built and released. And we were the only ones that are approving the changes to it. So how did we do that? Prompts. Command line scripts everywhere. We created scripts for deploying our components, Kafka, Zookeeper, Kafka Connect. Then we had configuration scripts to tell them how to be deployed. Then after they were deployed, we had scripts for creation of the things inside the clusters. We had scripts about scripts about scripts. It's a headache. So scripts, all these access, all these requests, how do you survive this in an enterprise? Well, the answer is actually simple. You delegate, you reassign responsibilities. What I don't want to do is be a bottleneck for others. So everything that they can do themselves, they should be doing. So we decided on a self-service approach where we had two groups, topic owners and application owners. And the topic owners define topics, the sizing, they approve access, they decide what the schema definitions are, and they are allowed to get contact information for application owners. The application owner can register the application and credentials. They request access to topics, and they can get the contact information for topic owners, which means I'm no longer in the middle. This helps you survive, of course. But it also introduces new challenges. We'll get to that later on our Kafka operations and where Strimzi comes in. So we finally removed all those scripts, and we could focus on operations, maintenance, onboarding, and support. So quick overview. This is what we created, a topic overview, topic data information, application information. But it's a success. We're an enterprise. The stakeholders are back. Some of them were ignored long enough, where they say it's now a success. Our requirements need to be taken into account. So we had some new requirements also for ourselves because we were going public with this solution. So we wanted it to run on Kubernetes. It should be multi-tenant, where each tenant can define their own topics, their own environments with the same names as another tenant without having fear of collisions. Tenants should not be able to even see or use each other's topics, both in Kafka or in self-service. And there should be secured public endpoints so that they could connect to it. All very straightforward. So again, how do we survive these new requirements? In this case, we started by introducing Strimzi. Well, we moved to the cloud for our solutions, VM-based deployments. It's not a problem, but Kubernetes was the future, and it's still very easy to deploy and maintain your infrastructure that way. So we moved to the cloud. We want to become Kubernetes native, and Strimzi is open source, has a very active community, but also very important, it's extendable and configurable. They have their own way of doing things, but give you the option to do it your own way. If you need if you have different requirements, you are mostly capable of using that. So where did Strimzi come in on these challenges, and what were those challenges? So at first we had the multi-tenancy. We needed authentication support, authorization, of course, and it needed to be very secure. So if I have multiple tenants on a cluster, I want to use naming patterns for resources. There were actually several presentations before now on multi-tenancy or partial multi-tenancy that uses the same approach. And you want to use those patterns for the predictable resources. Environment, it's the same thing. You can use the environment name in your patterns. And then prevent visibility and access across environments. This was a bit harder because that means we needed to set strict ACLs. You basically want to deny everything unless you allow it. Kafka supports it, Strimzi supports this, but we are multi-tenant, and these tenants are not even from the same company sometimes. So we needed to prevent same principal names be generated by accident. For example, if you use SSL by default, it uses your distinguished name. CN is my user. But if another company uses that same name, then they might get access to the topics of the other tenant, which is, of course, not allowed. So what was our solution? We enforce everything in self-service. We create unique SSL credentials. We can specify certificate authorities and include it in the principal names. And we specify which certificate authorities are allowed for certain environments, tenants. So it gets a bit and look like this. You have your deployments. The red, the yellow, and the green descriptions are the different tenants. They have multiple environments, and as you can see, sometimes they have the same name, like prod. We collect them inside what we call an instance, which is a group of environments that need to be deployed on one or more cluster. And then we basically deploy them with that pattern, with those pattern names and the ACLs, and enable replication between the clusters for those topics. So where Strimzi multi-tenancy is a bit harder because of the requirements we just had, especially the SSL TLS. We don't use the user or topic operators. The user operator creates for SSL TLS their simple formats of names, and not the advanced one that we want to use with the certificate authority as part of the principal name. And also, we didn't want any dependency or wait for resources to be created from our self-service point of view, which is, of course, well, you can debate that. For us, it was what we decided on. To allow this in Strimzi, we set an explicit super user, and we connect you to the cluster using the Kafka admin APIs. It means that we always can read the current state and apply changes. Because of our new SSL and requirement, we also needed to update the Kafka images from Strimzi, which they allow. We added our own principal builder, configured Strimzi to use that principal builder. And now it will add the certificate authority to the principal name. So Strimzi, by its flexibility and its extendability, allowed us to do this relatively simple. So what did we achieve? Well, we're now running on Kubernetes. We have a cluster that can support topics for separate tenants. There can be, they can reuse names and environment names because of the naming patterns. And they cannot see each other's topics because we generate all credentials and principal names and are in control that they are unique per tenant and across tenants. What have we not done yet? Well, we've not even touched the endpoints yet. So our second challenge with setting up this Strimzi and Kubernetes deployment is the external connections. We are running in a cloud. We own the cloud machines, but our customers are anywhere on the internet or have their own connections outside of Kubernetes. So how do we make sure that they are reliable and accessible to the Kafka is accessible to those customers? So first, we provide static public endpoints. We arrange IP addresses. We arrange the DNS entries, public ones for those that match those addresses. This means that now you can set up firewall rules or routing rules in your company networks. Of course, you need to set up external listeners explicitly for SSL and TLS and or for SSL. And you need to use these public names as your advertised listener. Well, Kafka supports all of this out of the box. So how do we did that in Strimzi? Well, after we need to secure the endpoint, we use TLS, of course, and the certificate with the subject alternative name for our URLs, of course. Sorry. So when you configure Strimzi, you can set up your own listeners. You can set per broker what kind of listener, you can set up a listener type, and then per broker, you can specify host names. You can specify what kind of connection it is, SSL or TLS encrypted or TLS authentication. So the first one we use is internal one, because when we communicate between our own systems, we don't want to go outside of our cloud and have extra traffic costs. And you can use network policy pairs to limit access to those internal listeners. But for the external ones, we specify load balancers or ingress, which allows us to specify the host name or IP address per broker, and we can generate certificates with those names accordingly. We turn on the authentication and the authorization with SSL and the client certificate. So now in Strimzi, we can set up all of these, and we can basically start. The end result would be we have a Kubernetes cluster now running, which can be used internally from your own apps and externally for customer apps. So did we have some more requirements met now? Well, yeah, basically our public endpoints are now reachable. Each of our broker has its own endpoint and a certificate signed with the relevant host, signed by the CA and with the relevant host name in the SUN list of the certificate. When you connect to Strimzi, it will offer that, and when the advertised host, the next part of the communication, will use those public addresses. Now, we have one final, and this is a big challenge, but thankfully something that Kubernetes was made for. It's about resource usage to get insight and to try to optimize it. So what are the challenges we have for resources? Well, we have the node sizes. We have in Kubernetes, of course, different nodes, and we assign that there are pods being scheduled to use those nodes. But how do we make sure that the right nodes are used for our Kafka, which needs a lot of CPU, a lot of memory? Also, how we make sure that other applications are not using that, for example. So that these are things that are quite common, but how do we do that with Strimzi? Well, we had to find out. We also want to monitor, of course, this resource usage and alerts when we reach those limits. And in the end, of course, optimize the configuration. So let's start with the sizing. We created dedicated nodes for Kafka. Like I said, Kafka is pretty high, has pretty high standards for their VM, for the CPU, their memory usage, and their disk usage. So you often want to use dedicated nodes to make sure that it can meet those performance requirements. Then we need to mark those nodes with some way to indicate what their sizing is or what they're supposed to be used for. And then we use the concept of affinity and anti-affinity to select the node for the proper size and usage, and to make sure that others pods are not allocated there. So what does it look like? We've done a bit of sizing here. We have our Kubernetes and we have a bunch of nodes running. The D1 are dedicated ones, and they are dedicated in this case for Kafka. We gave them some labels, and you can use different ways of identifying them. But now you have a label that it says this is dedicated for Kafka, and it's in zone Z1, Z2, Z3. Then we have nodes C, which are, as you can see, smaller in size. and they are the default runners. So we can use those for basically our components that do not require dedicated hardware. And that can be anything from schema registries to certificate managers and other utilities. So what does Strimzi offer? Well, it has two features that it offers for deploying the resources. One of them is the rack awareness, which is mostly used for partitioning, making sure that you can have multiple racks. And if you have a partition in replicas, it will spread the replicas as much as possible to different racks. If one of the racks fails or availability zones in clouds, it will continue to work because one of the replicas will take over. There's also the affinity and anti-affinity rules, which they made possible to configure. So the affinity rules can be used to say, I want to use a node which has the label dedicated and the value Kafka. And then I can use a different rule to say, you should not deploy this if there is already one deployed. Or there should be no system named X running here. These two rules, which are basic Kubernetes, are sometimes hard to set up, to tweak right, but make sure that you don't reuse your resources unless you absolutely want to. And you also don't get into trouble that if you reuse the same node, and let's say the load goes up, then the load goes up twice for both brokers maybe, killing your node. So we set it up that brokers do not share a node. Then we go into the monitoring, which again, you collect metrics from Kubernetes, from applications, from Kafka, you visualize them. And again, Strimzi offers everything already. You can export your metrics, you can export additional Kafka metrics with the Kafka exporter. You can enable scanning with the pod monitor so that Prometheus and Grafana can discover them. And we also enable node monitoring so we can see what each node is doing. And we add some dashboards based on the Strimzi also offers a lot of those. So this is for one of our clusters. You can see different loads, so the Kafka exporter data. Going to check about time. Well, alerting is important, of course, but before you can set up alerts, you need to know what normal is. So always track your CPU, your memory, disk usage for your nodes, your pods, and use your alert manager and your and these metrics to determine the values, the triggers for your alerts. Use Kafka-defined alerts. There are lots of documentation about what the metrics mean, what you need to monitor, where you should put an immediate alarm on, what you shouldn't. And then I'm thinking about under-replicated partitions, offline partitions, the sort. So Strimzi supplies the metrics collection for all of these things. And if you deploy the alert manager with Prometheus, you get those warnings. You can set up alert rules as well. You can monitor, you can update them in Kubernetes, maintain them, and then you can have call outs, that sort of thing. Highly recommended for highly available systems to do this. An example of some of the rules, these are based on the node's performance. And then when you optimize, you track CPU, memory, and disk usage. You, again, use these values and you start optimizing it. What's important to track? CPU memory usage. We often over provision, then realize we use memory or we use CPU. We assign it, but we never use it. Or the other way around, it's getting critical or it's reaching a boundary. We might want to give them more margin. Especially important to track here is the file system for Kafka, because it's very heavy on the file system, and too many files can break your Kafka deployment, your broker. So the number of partitions and the segment rules will determine how many files you have. Too many files and Kafka won't start anymore. We've had this a couple of times, very hard to recover from. Try to prevent this, monitor your files. And very important, use cruise control to redistribute your replicas to even your load. During production and scaling up, you will encounter imbalances. So now we can optimize our resources again with Strimzi. We have basically all our new requirements met. So the business event bus is currently still active. We now have 565 topics in production, over 1,800 topics for development, and 350 applications active, while reducing our maintenance team from 6 persons to a half FTE in 2021. So that's quite a way to optimize it. We survived. And even better, the business event bus is just one of the tenants sharing that single cluster. So it has 16 brokers, 2,700 partitions, 10 terabytes of storage in use, and 1,100 consumer groups. This is how we have survived with the help of Strimzi to scale up like this. Are there any questions? I think we're almost out of time already.
So there are no questions. We still have 10 minutes. So if you want to move forward, you can.
What do you mean, Paul? To move forward?
Oh, I mean, so that's the end of the session. So it's fine. No,
Yeah.
no. I was just saying if you have something more to show. There are no questions right now.
Yeah. I know this is a lot of text, a lot of things to do. If you want to have more information, just contact me. I'm on LinkedIn. I'm also on Reddit active with questions and on different mailing lists. We're happy to have a chat with you about your insights, my insights, not just from the sales point of view, but also just as a technical guy loving Strimzi and what they offer us.
So we actually have got a question for you, Richard. So Moritz is asking, are you using the CSI for local files provided by your cloud provider or local disks for the dedicated Kafka nodes?
What we're currently using, I'm not really sure of. I think we're using the CSI, but we have done setups with both, where of course the local disks for the dedicated Kafka nodes have a higher performance, but are also, in our experience, I think a bit harder to set up.
Thank you. So any more questions from the audience? We still have 5 minutes, or we can wrap up here and thank Richard for the session.
You're welcome. I'm glad to have joined you, and I hope you've all enjoyed StrimziCon as much as I have.
Yeah, sure. Thank you very much, Richard. It was a great session, and thank you for sharing our Axual is using Strimzi underneath your platform.
You're welcome.